This video will be a DPF related one because a lot of you asked in the previous one that I should make a or explanation video of how the DPF works, and surprise, one just turned up with DPF lights, and I intentionally didn't say DPF problems because I don't think the DPF has any issues whatsoever. So now let me talk about the car behind me, which came with the DPF light on, or if I correct myself, it didn't have the DPF light on because the owner's done a forced regen on it, but I still think that wasn't necessary, and let me explain you guys why. So the customer's complaint was that the DPF light came on, he scanned it for fault codes, I believe, and it was related to soot, ash accumulation, so soot and ash accumulation. And now finally let me turn or switch the camera and show you and talk about the car, what I believe the problem was. I have already disassembled the car because I was quite confident that I know what the problem is, and also a funny thing, the owner mentioned that he would bet his mortgage on that the DPF has the issues and not something else. But yeah, finally switch the camera and show you what we actually discovered. Firstly, what we can see straight away that the car must have a terrible fuel consumption and mileage per gallon, because we have nearly 3/4 of the tank and it can only do 232 miles. So as I said in the beginning of the video, the DPF fault is not always the DPF, or like the DPF being blocked doesn't mean there is a problem with the DPF, but maybe something else. And now let me connect the scan tool and show you the light data ratings, what I can see and what I can tell, and then I give you my initial like diagnosis or assessment or guess what I think will be wrong with the car. No fault codes present because the owner deleted it and done a forced regen, which I will get to it in a second or later in the video and explain why we don't prefer that and why we don't think that is a good idea. We only do it as a last resort. So because the car had a DPF light on or DPF fault, let's have a look at the DPF data first. As you can see, the accumulation of the particulate matter, it is 2.45. The DPF starts the region where those numbers reaches, I believe, 6.5, and there is also like very important like how quickly they rise or they reach the 6.5. So maybe you see they are at, let's say, 2.5, and they done 80 kilometers since the last region. So if you do the math, and it should do at least another 80 before the region. So that is an indication to me that the DPF is actually fine or would be fine, but I will get to that in the other part or like the second half of the video, like what I check when the car has a DPF fault and what are necessary steps to be taken initially to make sure there is nothing else wrong before we start actually diagnosing or fixing the DPF. But let's have a look at further data. Oil data hasn't been reset for 60,000 kilometers. What can that cause? It can cause the oil lamp to come on and triggering a low oil pressure warning light. Sometimes, if the owners are lucky, when they have the oil pressure problem, it's just the matter of fact that someone didn't reset the oil data light or data point for so long. But what I want to show you is more interesting. The car has the new exhaust pressure sensor. I believe the owner has it replaced himself. So have a look at the data. The data or the live data, the values are fine. 107 kPa on idle, which is fine. But what I'm going to do now, I'm going to press the throttle, raise the RPMs till 3.5, 4,000 RPM, and see how those values will be changing and how those behave. So let me do that. Those numbers are still climbing back, what means that the exhaust pressure sensor pipe is blocked with carbon, and that's why it cannot go back to the normal values as quickly, and it doesn't even raise or rise as where it should raise at least. And the other thing what the car does, let me try to rev it and you will see. So I'm going to rev it till I can, or full throttle, and see what happens. it doesn't want to go over 3,500 RPM. So yeah, let me know in the comment section, guys, who already may know what that is. So the car is disassembled. It had quite a lot of things done on it already, which was camshaft replacement, if I'm correct, by Mazda. I didn't record when I was disassembling or removing the valve cover. There were like quite a lot of things not done properly again, but this is not a video how to do it properly, what needs to be done. We can verify and confirm that the camshaft is not worn, shouldn't be worn. Also, let me know, guys, if you want to see a video from me, like to explain why I believe or what I think the camshaft is worn or how it wears. I can do a separate video on that. You can notice that the exhaust pressure sensor is removed, which is here. This is actually the upgraded one, the new one, the metal one. The previous versions are plastic and they can go bad because I believe from the extra or the lot of heat, the plastic goes bad. Yeah, so this is, if I take off the rubber hose, the tip of the sensor will be from metal. So this is the upgraded one, but yet the car has exhaust pressure related fault codes. I will show you that in a second, what that means and how to get rid of those, how to fix them. So that was the main reason we took off the valve cover. And now let me show you what I believe is the reason for the DPF being blocked. Just have a look at that heavy, massive carbon buildup. So as you could see from the previous clips that I recorded in the cabin, that was pre-recorded already. So I connected the scan tool and show you the live data, and also I showed that the car wasn't revving over 3,500 RPM. That's because of the huge massive carbon buildup blocking the air getting to the combustion chamber. Combustion not perfect. So now what I'm gonna do, I'm going to get rid of the carbon. I'm going to show you the after results, how they look like. Unfortunately, I can't show inside the intake port because it's so blocked. I can't even stick down the bore scope into the hole. But I'm going to show you how it looks like. Also, I'm going to show you the process of getting that exhaust pressure sensor pipe free flowing of air. I'm going to show you that. And let me switch the camera one more time and I'll show you one another thing. So even though the drive belt is replaced, if you have a look, the drive belt looks very new, but if we have a look from here, you can see it has like it's already torn. They may have like damaged it during the installation. So the piston in the cylinder number 4 is, or the valves are definitely closed because the camshaft, the intake camshaft lobes are not pushing down the rocker arms and it's not opening the valves. So I know these two valves are in a closed position. I'm going to clean them too. Then I'm going to stick down the bore scope and make them open so I can do the rest of the holes, and that will be it. That's how I'm going to make sure that the piston is in the top dead center in the cylinder number 4. Meanwhile, Ben is rebuilding an engine which is going to go in a car which has a rod knock. So he already fitted a new cylinder head. This was pressure tested and schemed in a machine shop. New exhaust camshaft. So yeah, he's doing that, and then in the background is working on the car which came from Scotland all the way from Glasgow. This car has quite a lot of issues. I'm going to include a clip of the failed turbocharger, how that looks like. Funny thing, it had the broken off flap, yet it didn't throw a fault code. Also vacuum pump failure because it was a fault code for that, and I believe he already replaced the camshaft. Yes. So the new camshaft is installed, and also he already replaced the strainer, but the car still will have the carbon cleaning done on it, and yeah, we can return the car back to the customer after that. So on the cleaning of that pipe, few of you have already asked like how you can clean that without taking the valve cover off. I don't believe that you can. Some said that you can do with the wire and all that. Feel free to try it. I'm not against. It's if it works, it works. Doesn't matter. But also, I don't really encourage spraying anything in that hole. Even though I said like, if it is not too savvy, you can actually clean it with some kind of spray. But if the blockage is very bad in that pipe, what can happen is when you spray something there and try to get it out, what end up happening is just you pushing it down further and making it more solid, so you'll have a hard time removing that what's inside. Again, ask me how I know that. We had a customer who's done it, and we believe we removed or like got that pipe cleaned. It took us like good 30 minutes. So now I'm going to ask Dan to help me. I'm going to record him on camera because he's so eager and so keen to get this job done. He loves it. He loves playing with fire. So I'm going to ask him. I'm going to pressurize that pipe with air and show you that it is blocked, and also after the cleaning I'm going to show you that it is free flowing of air. Now he's going to pressurize it, and it's so blocked it tries to come up the same way as he's pressurizing it from, not from here of the EGR cooler connection or hole. And now what he's going to do is going to use the blowtorch, heat the pipe up. If you wouldn't know, guys, it's very dangerous. If you ever do this, be very careful not to fuck up something. As you can see, it is burning. The carbon is burning in there and the pipe is glowing red from the heat. It didn't work on the first attempt, first try. Now he has to heat the pipe again a bit more for us to see the fireballs. Still no sign of smoke coming out from the EGR cooler connection, which means that that pipe is way too blocked, but we don't give up. In the meanwhile, while we are struggling still removing or cleaning that pipe, here is another one from the engine which Ben is rebuilding. So have a look how bad that is. Hopefully, let me try with different. See that carbon build up in that tiny pipe. So imagine you spray something in there, you soften up the carbon, but as you push or press it down, it goes up further, it goes further down and it becomes solid, and that it will be impossible to remove or close to impossible. Now Dan is trying to demonstrate how we burn it out or how we get it cleaned. So it's all trying to escape from the top. He's going to heat it up. Obviously on the car, when it's in situ, we can only have access till this length of the pipe. We don't have access to all the way down to the banjo bolt. And also there is a tricky part to it because the banjo bolt hole is so tiny, so you need to do it sometimes quite a lot till you get it completely clean. And just have a look how the carbon is burning out from it. and have a look. As you can see, it's glowing in here, so there is the blockage because the carbon is on fire. You can actually see how that is moving down to the banjo bolt hole, which the banjo bolt is supposed to be. And as you could hear, guys, now this pipe is clean. Let's get the same done on the Mazda CX5. So yeah, that took us good 10 minutes definitely to clean that pipe. So I've done with 2 ports. Let's have a look at the massive difference. So you see those are still full with carbon and these ones are done. Huge difference. Let's have a look there with the camera. So look at the valve, it is clean. And also I got asked sometimes in person, like, how do we do it, what is it called, why is it called a walnut blasting machine or walnut blasting method? Because guys, literally these are crushed walnut shells and we blast the ports with these ones. These are softer than the actual sandblasting. So basically it's kind of sandblasting, but the material is softer. Material is softer and it doesn't damage the valves. So it doesn't damage the lap of the valves, so they won't leak air and the car still will have the compression. That's how we do it. Now I'm going to use still the camera, open those 2 valves, and then the rest of the valves will be in closed positions so I can get those done. How I'm going to turn the crank, because the car is manual, I'm just going to put it into 4th gear, lift one side of the car and turn it by the wheel. If you know why is that possible, let me know in the comment section. If you are like unlucky and you have automatic car, what you need to do, you can take off one wheel, obviously lift one side of the car, take off the wheel which is on the crankshaft side, and then you can turn the engine by the crankshaft bolt. That's how you make sure that the valves, when you are working on the ports, they are closed. So now I'm going to do exactly that and get the rest of the holes cleaned and show you it on the bore scope, and also like take like a grand take a picture or take a clip of it, like how they look when they are clean. I have finished with the rest of the holes. I still need to obviously touch up the mating surface, but that's the least of the things or the worries. Now let's have a look the ports. As you can see, clean for carbon again. So now the last thing I'm going to do is to assemble everything back together and then change also the drive belt, turn on the engine and then show you the live data. We're going to take it for like a longer test drive to show you that the DPF will be fine and it's actually doing the regens not that frequent as it was maybe doing before. So I am going to take this one for test drive. We've done exhaust pressure sensor, pipe cleaning on it and carbon cleaning. It had a DPF light on. Very likely the video has not been out yet, so this is where you can see it for the first time. So I'm going to start it up. Still need to bleed the coolant system and then I'm going to do few adaptations and resets and see if the DPF light will come back on or if the regen frequency has improved. The engine is running now, and let's have a look if it does rev over 3,500 RPM as it wasn't before. Yeah, now let me connect the scan tool and also check the live data if there is any improvement. What I'm curious about is those pressure sensor values. So they are fine. Obviously they were fine before as well. What the problem was, when I revved the engine, they weren't moving up. I believe they went only up to 150 kPa and they were struggling to come back. But now the pipe is clean, so now let me rev the engine to 3,500 RPM and see how the numbers are moving. Yeah, they are moving quickly. So now I'm going to let the cooling system to bleed, do the reset of the adaptations, and then take the car for the test drive. I'm back from the test drive. I triggered a DPF region. Have a look at the DPF numbers. I would say averaging 0.1, which is very low. Obviously it just had a region. Let's have a look. As you can see, I also done the injector reset, and I still need to do the pilot learning. Have a look at the correction factors. They don't look bad, let's say, except injector number 1. We will check back after the pilot learning, but I want to see the DPF numbers or values. Yeah, those numbers are very low, the accumulation of the particulate matter, because it just had a DPF region. But even before the car got to us, the numbers were quite fine. So the owner had 80 kilometers done before the last regen, and those numbers were below 3. So that meaning DPF was halfway full or halfway close to the regen. So as I said, the DPF light wasn't on because of the DPF fault. So I'm still going to get the pilot learning done. I'll show you the results after the pilot learning of the injector correction factors, and then in the rest of the video I'm going to explain why the DPF is getting blocked, so stay tuned for that as well. Okay, pilot learning has been carried out. The numbers, I would say, improved. They are still in the range, so it's okay.